Assalamualaikum and hi, we are from group 3. We are going to present our project. Topic that we choose are electromagnetic wave propagation and the title is resonance charging. This is our group members, me Noraihan binti Muhammad Nazri, Muhammad Faris Ridwan binti Amran, Anas bin Adnan, Zubair Adil Somro and Nur Ainatul Shakina binti Firde. I want to present the introduction for our project. Wireless power transfer has two types, which is radiative and non-radiative. Radiative depends on the far field technique, but non-radiative use near-field inductive coupling or resonant coupling. Non-radiative wireless power transfer suitable for short-range and mid-range applications. For short-range applications, ordinary non-resonant capacitive or inductive coupling can transfer practical amounts of power, while mid-range applications, resonant capacitive or inductive coupling can transfer practical amounts of power. Inductive wireless power transfer techniques based on a simple transformer in which a primary coil is supplied by an AC power. IWPT technology can be used for several kilowatt applications such as charging electric vehicles. IWPT is the promising near-field simple technology having short transmission distance up to a few centimeters. Although it offers higher power transfer efficiency for the charging path between transmitter and receiver but needs accurate alignment. Examples of IWPT technology are charging pads for cell phones, laptops, electrical vehicle charging, and chargers for electrical toothbrushes. Resonant wireless power transfer techniques. To achieve the improved power transfer efficiency, the leakage inductance is compensated by utilizing the techniques of magnetic coupling and resonance together. RWPT is also a near-field technology and appropriate for mid-range applications from few centimeters to few meters. The effective power transfer efficiency, which is PTE, over a few meters distance can be achieved in RWPT technology, but the switching frequency of RWPT is often much higher as compared to IWPT. Comparison between IWPT and RWPT. Both the IWPT and RWPT technologies are using the same technique of electromagnetic induction for transferring the power. Therefore, they will be merged into one technique shortly. That's all from me, and I will pass the next part to Faris. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Ridwan binti Amran and my metric number is DE180165. For now, I will present about the problem statement. So firstly, the wireless power transfer are divided by two, radiative and non-radiative. The specification for AC frequency for this device is 110 and 110 to 205 kHz for power up to 5 watt. Secondly, 80 to 300 kHz for power up to 120 watt. This device can be operated from a 5-volt USB power supply. So what the difference between inductive coupling and resonant coupling? Inductive coupling, the magnetic field created by the primary coil radiates in all directions and flood drops depend on the distance. Second, the secondary coil must be placed as close as possible to the primary to intercept the most flux. But in resonant coupling, a system that transfers power between coils operating at resonant frequency, it is still the same concept of inductive, but it uses the strong coupling that occur between resonant coil. And lastly, it can get the same result even separated by 10 of centimeters. The question is this technology safe for people usage? And secondly, in these two different technology, which one is more efficient and convenient? And now I will continue on our objective for this project. To potentially identify the efficiency of wireless power transfer between inductive coupling and resonant coupling. To investigate whether wireless power transfer is suitable to be used in people's daily life. And lastly, to explore the old technology that are rapidly used in mobile device nowadays. That's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zubir Jastamru, metric number AE180108. I'm going to talk about the project framework for our project, the resonance charging. Okay, this is the block diagram for the wireless power transmission, our wireless pad. There will be AC supply will be directed from the power outlet into the charging the wireless charging pad. Inside the charging pad there is an inverter which converts the AC to DC, and then that DC will be converted to high frequency AC amplifier, so that we can choose any high value of frequency that we want to specify inside our wireless pad, so that on that particular frequency the device can transmit its signal, the wireless signal through the transmitter. For suppose if you want to put 50 gigahertz frequency, then the transmitter will transmit that 50 gigahertz frequency into the passive repeater. This passive repeater um, will increase the potential or the wireless potential, so that more higher higher signal can be transmitted for a further distance. Then it will received by another receiver, which will be inside the device, like such as smartphone or other devices. And then that device will convert that high frequency into the DC rectifier, so that the signal, the wireless signal that it's transmitted from the charging pad can work in the circuit, because the circuit works in the DC voltage 0 and 1. Okay. Figure 2, that figure shows the wireless power transfer. The AC supply will be converted into DC. So likewise I was saying that I want to choose 50 gigahertz. In here I specify it's 6.78 megahertz. So this is the higher frequency. Okay, the circuit is designed such way so that the impedance of transmitter and receiver circuit matches. So this IMC circuit is used so that the impedance of the transmitter and the receiver is same, so that the efficiency is higher, more than 50%, about 70 or 80%, so that all the wireless transmitted signal can be received to the receiving resonator. Okay, the high frequency current is routed through a coil. There is a coil inside this resonator which allow the signal to be transmitted. The current inside the coil circulate in a circular shape, and that will produce magnetic field which will transmit the signal, and that signal will be catched by the passive receiver and then amplified. Then that amplified signal will be received by the resonator. Okay, this is the block diagram of the passive repeater. That the passive repeater gets the input signal, the magnetic field, the magnetic field inside the passive repeater. through its receiver, and then that is amplified and equalized the signal. Then the amplified signal goes through the timing circuit and then go through the regenerator so that it can regenerate, and then through the transmit it can transmit that amplified signal. Okay, this is the passive repeater is used because so that the signal will be still detectable even though the distance between the device and the original wireless pad is larger. Okay, this is the prototype. It's a rough sketch. This is the power outlet into the wireless charger and then through the repeater into the device. Okay, these are the prototype model. Okay, this we can use any kind of wireless charger here, with either Z, you can use Samsung charging pad, and repeater is also we can find in the market if there is one, or otherwise we can design it. Okay, any device can be charged. You can use mobile phone, multiple device, 2 3 up to 5 devices. Okay, that's all from me. Thank you.
Hello, my name is Anas B. Adnan, and today I will explain about the expected result of our simulation design circuit model. In designing resonance wireless power transfer or transmission model, there are two aspects that is important, which is power transfer efficiency and resonance frequency. We use the MATLAB simulating software to run our schematic design. The first aspect is power transfer efficiency, which its formula is P out over P in times 100%, so we get the efficiency value of the system. And for the second aspect is resonance frequency, which is we use the formula F equal 1 over 2 pi square root L times C, which is L and C is inductance and the capacitance value of coil. So we come out a two circuit model, which is first one is for the charging cell phone. This circuit is divided into two parts, which is here is this part is for transmitter winding coil, and for this part for the receiver winding coil. After we run the simulation, we can calculate the power transfer efficiency of the circuit, which is for the transmitter part we get 60.66%, and for the receiver parts we get 26.85%, which is it is decreased value of the efficiency. And here our graph simulation from the circuits. First circuit, as we can see, this is for voltage and current output graph, and for this graph is power output graph. In order to achieve desired efficiency, we come out for the second circuit designs. which is this is the circuit. From the circuit, there are two resonators. We put two resonators in the circuit, which is L1 and L2 here, with the AC source only. After we run the circuit, so the output we calculate the efficiency of power transfer of the circuit by using the formula power PAC out over PAC in the times 100%, which we get 79.56%, and it is achieve the efficiency of the system, which is we have to achieve more than 75%, and we calculate for the resonance frequency by using the formula, and we get 90.915 kilohertz. After we run the circuit, we get a sine wave form graph, and from the graph we get 90.85 kilohertz, which is it's approximately with our calculation, which is 90.91. So the result is valid, and the below graph is for voltage and current output versus time. Thank you for listening my explanation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ainatul Shakina binti Filde, and I want to present about the conclusion. Wireless power transfer has the potential to change this planet on so many different levels, whether it is changing a handheld device to changing the effect of global warming on this planet. We can see by the wireless power transfer. WPT is the most commercially usable application appear to counter the effects of global warming and the increasing demand for electricity through microwave transmission from space. Technology companies can broaden the capabilities of most small electronics with WPT through the resonance and inductive coupling, including cell phones, PDAs, and MP3 players. Earth's future could be dependent entirely on wireless power transfer, so it can make the improvements to this Earth are amazingly, even though the actual process does not produce any energy. The example of having power anywhere at any time include pollutant-free electricity, reduction of fossil fuel demand, a solution to the oil crisis, increased safety for medical procedures, and the mobility. Nowadays, wireless power transfer is the most marketable and sustainable alternative to fossil fuel power plants. So, indirectly, with the advancements in the field happening all the time, a worldwide wireless power transfer system is a possibility will exist shortly. That's all for the conclusion, and thank you.